So we were studying these celebrity limits. The limit is x goes 0, sine x over x equals 1. Now you realize this would be the same if you had the limit as x equals 0 of x over sine x. That would equal 1 as well. So this ratio right here as x goes to 0 is 1. Now you have to be careful though. When you're in calculus and you're working with this limit, you realize that we found this limit based on we were in radian mode. We were working with radians. If you tried to find this limit graphically when you're in radian mode, you would find the limit would be 1. However, if you tried to find this limit and you were in degree mode and you were using your calculator and graphing it, or using a numerical approach, you would find this limit to be pi over 180. So you have to, this is dependent upon x being in radian, in radians. Now also, and so that's the assumption we're going to have always, that we're working with radians. Now also we have this limit, the limit as x goes to 0 of 1 minus cosine x over x, that equals 0. Okay. Now, knowing these two things will help us in evaluating some limits. And I want to show you. Now, you had some in your assignment, but these are kind of special cases. Let's think about this limit right here. This kind of looks like a challenge because we can see how there's a possibility we would use this notion right here. But this looks a lot different. It's sine 2x over sine 3x. So the way we want to play this game is we want to see if we can get something that looks like this. Because if we can get at least part of this that looks like this, maybe that will help us to evaluate this limit. Otherwise, it might be a challenge to us. So think about this. Let's think about what if we do this little trick. So a lot of times in mathematics, a problem boils down to just recognizing a trick, some kind of trick. In this case, I'm going to notice this. What if I just multiply sine 2x over sine 3x? What if I just multiply that by 1? I can certainly do that. I can multiply it by 1, and that doesn't hurt anything. Well, instead of 1, what if I just multiply the top and the bottom by 1 over x? In other words, I'm still multiplying by 1. It's just 1 over x divided by 1 over x, right? So that's still, that's still 1. 1 over x divided by 1 over x is 1. So I've broken no laws here. Now, once we do that, notice we could rewrite this problem this way. We've got the limit as x goes to 0 of sine 2x over x over sine 3x over x. Yeah, there we go. That works, right? Now, at this point, this is starting to look a whole lot more like this thing. Because up top, we've got sine 2x over x. On the bottom, we've got sine 3x over x. Now, so that I don't have to work with this fraction, let me just do this. Let me make this the limit as x goes to 0 of this thing. Sine 2x over x times x over sine 3x. See what I did? I just inverted and multiplied, right? I got this top over the bottom. Let me just invert and multiply. And that's what I did there. Invert and multiply. Okay. So that was just a little trick. So now I've got this. I've got, if I can figure out what this limit is here and this limit, I'll just multiply them together. See, I've got a limit of a product is the product of the limits. That's the situation I have here. So let's do this. Let me scoot the camera over a little bit, give myself some more room. Okay, so watch what I can do. I can say, well, This one right here, I know what to do in a situation like this. I can multiply the top and the bottom by 2. Because what I need to use this limit right here is I need what's inside here to be the same as what's on the bottom here. So let me do this. I've got the limit as x goes to 0 of 2 sine 2x over 2x. Yeah, all I did was multiply the top and the bottom of this one by 2. And that doesn't hurt anybody. Okay, that's just something we can do. We can multiply by 1. Then I'll do the same thing for this one. I'll multiply the top and the bottom of this one by 3. So I've got 3x over sine 3x. Well, there's a 3 down here as well. Okay, now this is a little sloppy here on the end, but you can see what I've got here. I've got 2 sine 2x over 2x. I've got 3x over 3 sine 3x. And so we're doing some tricks here. So now let me rewrite this. Look, I'm going to take this first part, this 2 sine 2x over 2x. I'm going to factor out the 2, and I've got the limit as x goes to 0 of sine 2x over 2x. See, I just factored out this 2. And then times, let me go ahead and give it its own limit. It deserves its own limit over here. This is, let me put a 3 on the front. 3, no, not a 3 on the front, a 1/3 up front, right? So I just took this 1/3, and now I've got 3x over sine 3x. See? So what I did was I took this 1/3, put it on the outside. So dig this now. I've got 2 times this limit times 1/3 times this limit. Well, this limit, the limit is x goes to 0 of sine 2x over 2x, that's 1. So what I've got now is I've got 2 times, this limit here is 1, and I've got a 1/3 there. So it looks like that limit is 2/3. Okay, so this whole limit here is 2/3. And I just did that little trick. So this limit right here is 2/3. Okay, sorry about the messiness down here. It's really messy, but anyway, I think you can use your imagination to see that I factored out the 1/3 there. Yeah, okay. Now, so that's one example of where this comes into play in evaluating these limits. Now, if you come down here, look at this one. This one is it's reminiscent of this, right? We've got 1 minus cosine over x. Okay. But it's not exactly that. And then we've got sine x over x squared. So we've got this x squared down here. So here's what we need to do. We need to get this in a form that we can bring those celebrity limits into play. So look, I've got x squared down here. Why don't I do this? Why don't I write this as sine x over x times 1 minus cosine x over x. See, I kind of split it up there. See? I put the sine x over this x, and then 1 minus cosine x over another x, and then if you multiply those together, you get x squared. So that little trick serves us well, because now, look what we've got. We've got the limit as x goes to 0 of sine x over x times the limit, I'm just going to go ahead and give it its own limit, 1 minus cosine x over x. And now, look at this. This is perfect. This is 1. This is 0. And 1 times 0 would be 0. So that limit is 0. So this is these are two examples of where you play around with a little bit and you realize these basic limits. So then you can use that and maybe manipulate these various limits that you come across to help you to evaluate them. Now, I want to look at this one. Okay. This one, now remember, the first thing we try to do is plug in here and see if maybe we can just plug in and find this limit. And if you do, you get 0 over 0 because tangent of pi over 4 is 1. 1 minus 1 is 0. And then tangent of pi over 4 is the same as cosine of pi over 4. So you get 0 in the top and the bottom. So what we do in a case like this, and basically what we're doing is we're just studying, we're seeing how to deal with limits that involve trigonometry, that have trig functions in them. And we're saying these can sometimes help us. But what about this? So, well, we don't just have those limits that can help us, those celebrity limits. We also have trig identities. And a lot of times, what we want to do is we want to apply our trig identities in some way. And now, one common way to approach a situation like this, a trigonometric expression, is to convert everything to sine and cosine that's not already there. Like, this is just a path you can take. I could say, well, tangent is sine over cosine. Okay, sine over cosine. You might say, well, congratulations, you've got something that looks more complex. Well, but what if, now this is a complex fraction here, we've got this extra denominator. So what if we do this? What if I multiply everything by cosine? What if I multiply this by cosine, and the bottom by cosine? See, I'm just multiplying by cosine over cosine, and there's no harm in that because I've just multiplied by 1. Well, if I do that, look what happens. The cosine cancels there, and up top, let me rewrite the limit. I've got the limit as x goes to pi over 4. Whoops. I need to adjust my camera a little bit. Okay. There it is, pi over 4. And now, up top, I've got this. I've got 1 minus sine. No, cosine minus sine, I'm sorry. Cosine minus sine. Sorry about that. Cosine minus sine. That's what I've got. That's what I've got up top. Now, down on the bottom, I've got cosine x times, well, sine minus cosine, right? Nothing's changed. I thought I was going to distribute through or something, but I'm not. Okay. Now, look at this situation. Cosine minus sine, sine minus cosine, those are opposites. It's like if you have 5 over negative 5. Well, you divide them and they're negative 1. So let me cancel these out, and I got negative 1 up top. So let's look at our limit now. Our limit is now, as x goes to pi over 4, negative 1 over cosine. Okay. Well, now it's kind of easy because all you got to do is plug in, right? Cosine, remember, is 1 over the square root of 2, or square root of 2 over 2. I'm putting it this way because now, notice I just flip it and I get negative square root of 2. So that's the limit there.